continue. Question 7. It is given that v varies inversely as the square of t. Some corresponding values of v and t are given in the table below. We have that table. Find the values of k, the constant of variation, a and b. So we'll do that step by step. So when they say varies inversely, this is what you're supposed to do. You put 1 over. If it was direct, if they say varies directly as, you don't put 1 over. But the moment they say inversely, so it means that v varies inversely, you put 1 over t squared. Now, where there's a 1 here, replace a k. That is a constant. What constant is here? So we'll take it step by step. We are going to use 2 and 25 because these are numbers which we can use to solve for k. So we are going to take it step by step. Where there's v, we'll substitute a 25, and where there's t here, we'll replace a 2. So let's do that. So we have 25 is equals to our constant k over 2 squared. Now if you have 2 squared here, it means multiply 2 by itself. Multiply 2 by itself twice, which is going to give us a 4. From here, what are we supposed to do? Express 25 as a common fraction by putting a denominator 1 and cross multiply. Therefore, our k is equals to 200. We continue. Now, v is equals to 100 over t squared because we know our constant now is 100. Instead of saying 1 over t squared, we'll just go straight to replacing our 100. Or instead of saying v is equals to k, which was a constant, over t squared, we just go straight to replace 100. Then we have to solve for a, according to the table we've been given. So where there's t, we'll replace a 5. So if you square 5, what are you going to get? A 25. Therefore, our a is equals to what? To 4. We continue. Since we know that v varies inversely, we know our k is 100. Where there's k, we'll replace 100. We've been given as v as 1 over 4. When t is equals to b, we have to solve what t is. So from here, we are going to replace. Where there's a v here, we'll replace our 1 over 4 is equals to 100 over, we know our t is b squared. From here, what are we supposed to do? We'll cross multiply. So we are saying b squared times 1 will give us b squared. 4 times 100 will give us what? 400. When you multiply 1 times b squared, you get a b squared. 4 times 100 is giving us a 400. From here, what are we supposed to do? Introduce the square root on both sides. Introduce the square root on both sides. You'll find that b squared to the power 1 over 2 is going to give us a b. And then which number are you supposed to multiply by itself twice to get 400? You find that we have 20 and a negative 20. So if you multiply 20 by itself twice, you get a 400. If you multiply negative 20 by itself twice, you get a 400. Therefore, our b is equals to 20, or b is equals to negative 20. We continue. We have question 8, which is saying solve the simultaneous equations. 2x is equals to 5y, x minus 2y is equals to 3. Simultaneous means to occur at the same time. You can use 3 methods to solve that. So they're saying find the same value of x and the same value of y to make those 2 equations into true sentences. Let's do that. We are going to use the elimination method. But before we do that, we have to standardize the first equation. So what we are going to do is to transpose this positive 5y, move it from the right hand side to the left. It will become a negative, which is equals to 0. Now, you cannot eliminate when the coefficients are not the same. The coefficient is the number before the letter. So here my coefficient is 2. Here my coefficient is 1. Here my coefficient is negative 5. Here my coefficient is negative 2. So these cannot be eliminated unless the coefficients are the same. So to make them have the same coefficient, I'll multiply the first equation by 1 and I'll multiply the second equation by 2. so that I have a coefficient 2 and 2. Let's do that. So when I multiply the first equation or the whole equation by 1, I'm getting 2x minus 5y is equals to 0. When I multiply the second equation, I'm saying 2 times x, 2x. 2 times negative 2y, negative 4y. 2 times 3, 6. So from here, I have the same coefficient 2. Now, since the signs are the same, what are we supposed to do? We'll subtract. So I'm saying 2x minus 2x is giving me 0. Negative 5y minus 4y. So this negative here and that minus is giving me a positive. 0 minus 6 is giving me a negative. So if you have negative 5y plus 4y, it's going to give us a negative y. 0 minus 6 will give us a negative 6. When the coefficients are negative, what are we supposed to do? Either multiply the whole equation by negative 1 or divide both sides by a negative 1. Your answer will be y is equals to 6. But this is not supposed to remain like that. We've just found y. We are supposed to solve for x. So we use the first equation where we'll say 2x is equals to 5y. When y is equals to 6, it means where there's y here, we'll replace a 6. So we are saying 2x is equals to 5 times 6. 2x is equals to 30. To find the value of x, divide both sides by the coefficient, which is 2. Therefore, our x is equals to 15. Finally, we are going to say x is equals to 15 and y is equals to 6. That is our answer. We continue. We have question 9, which is saying a set has 16 subsets. Find the number of elements in the set P. Find the number of elements in the set P. When you're looking at the number of subsets, the number of subsets is the set which is contained in another set. So the formula we use for the number of subsets is 2 to the power n. So we are saying 2 to the power n is equals to 16. Express 16 in power form with a base 2. What is 16? 16 is the same as 2 to the power 4. From there, what are we supposed to do? Equate the powers. Since the bases are the same, we have base 2 and base 2. What are we supposed to do? Equate the powers. So n is equals to 4. Therefore, the number of elements in the set is what? Is 4. We continue. On the Venn diagram in the answer space, shade the region represented by P complement intersection Q. We have that Venn diagram. They want us to shade the region P complement. Complement means outside P, intersection Q, inside Q. So outside P is all this region from here. All this region is outside P, but they are saying inside Q. Outside P, but inside Q. So it will look like that. That is the region P complement intersection Q. Complement means outside, intersection means within. So we are looking at the region outside P, but inside Q. We continue. We have question 10, which is saying, given that f of x is equals to 12 minus 3x, find f of negative 3. Now, a function is a relation. So if f of x is equals to 12 minus 3x, it means f of negative 3 will be equals to, where there's x, we are going to replace a negative 3. That's what we are saying. So we are saying f of x here is 12 minus 3x. Now, f of negative 3 will be equals to 12 minus, where there's x here, there was x there. We'll replace that negative 3 here. So from there, we are going to say 3 times negative 3 times negative 3. When you are multiplying a negative times a negative, you get a positive. So we have 12 plus 9, which will give us what? 21. We continue. We have f inverse of negative 3. The inverse is the opposite, where you make the domain the range and the range the domain. So what we are going to do first, we are going to say f of x is equals to 12 minus 3x. Where there's f of x here, replace a y, substitute a y. Then we are going to say y is equals to 12 minus 3x. From here, what are we supposed to do? we are supposed to make x the subject of the formula. We are supposed to make x the subject of the formula. So we'll take it step by step. We'll transpose this negative 3x to the left, it will become a positive. We'll move this y from the left to the right, it will become a negative. From here, what are we supposed to do? To just remain with this x, we'll divide both sides by the coefficient, which is a 3, so that we remain with just x. So if we divide both sides by 3, we are going to remain with x is equals to 12 minus y divided by 3. From here, that's where we can now say f inverse of x is equals to, where there's y here, replace x. Replace x, it's a must. So we are saying f inverse of x is equals to 12 minus x over 3. Now we can find f inverse of negative 3. It means where there's x here, we'll replace a negative 3. So we are saying 12, when you have a minus and the negative is the same as plus. So we are saying 12 plus 3 will give us a 15. Divide 15 by 3, what are we going to get? A 5. We continue. We have question 11. A box contains blue, green, black, and red marbles. Given that probability green is equals to 2 over 5, probability red is equals to 1 over 4, and probability black is equals to 1 over 5. But we've not been given the probability for blue. So the question is saying find probability blue. Now, when you're looking at probability, the probability of picking blue, green, black, and red marbles, when you add the probabilities, they are supposed to give us a 1. When you add the probability of picking a blue, green, black, and red marble, it's supposed to give us a 1. So since we don't know what the probability of blue is, you are supposed to say 1 minus the probability of green plus the probability of red plus the probability of black. Let's add. So we are saying probability of green is 2 over 5, probability of red is 1 over 4, probability of black is 1 over 5. So we are going to solve what is in the brackets first by finding the common denominator, which is 20. 5 into 20 is giving us 4. 4 times 2, 8. 4 into 20, 5. 5 times 1, 5. 5 into 20 is giving us 4. 4 times 1, 4. From here, what are we supposed to do? Add the numerator. Add the numbers on top. If you add 8 plus 5 plus 4, you get 17. So we have 17 over 20. From here, we are going to find the common denominator, 20. So we are saying 1 into 20 is 20. 20 minus 17 is giving us 3 over 20. That is our answer. Now, probability of any event occurring, it is equals to favorable outcomes over total number of outcomes. So our total number of outcomes here is 20. We continue. Find the least number of marbles that must be in the box to suit these probabilities. So what we are going to do is we are going to look for the lowest common multiple of 4, 5, and 20, which is 20. So all the possible outcomes were how many? 20. So they are saying there were 20 marbles in the box. We continue.